Hi! In this recording, I will briefly introduce packit features that can be utilized in upstream. Besides the automation to Fedora described in the previous recordings, packit can be also configured in upstream projects where it can act as a CI solution and validate the upstream changes against downstream distributions such as Fedora or CentOS stream. Packit currently operates mainly on GitHub, but there are also a few users in GitLab, GitLab GNOME, or GitLab Free Desktop. So what can Packit do in upstream? It can build RPMs, test RPMs, or in general run tests, and build virtual machine images. Let's now have a look at how to set up Packit so that you can start using the features. To enable Packit in upstream, you need to follow a few simple steps. Firstly, you need to install the application itself. In GitHub, Packit is an app which you can find in GitHub Marketplace, and in GitLab it is an integration, so you need to set up webhooks as described in our documentation. As a next step, you need to be allow listed. We currently allow list users with valid Fedora account system accounts. In GitHub, you can do the verification yourself automatically, as you can see in the screenshot, and for the other forges, you just need to contact us and we will allow you manually. The last step is creating a configuration file and placing it in your repository. For most of the packit features, you will need an RPM spec file, which you can either place in the repo as well, or define a command or script to download it. This is of course not needed if you are only running tests without building RPMs. So that Packit knows what and when should it run, concept of so-called jobs is used. Each job represents a feature of Packit. The jobs are defined in the configuration file, where you can specify the type of the job, when the job should be run, and additional information needed for the job, such as what targets to build, what branch to run the job for, etc. So let's now go through these jobs. Firstly, we have the copper build job. This job builds RPMs in copper build system. It can be configured for pull requests, commits, or releases. It can be used to verify that package is buildable, to be able to easily install package including the proposed change in a pull request, or to provide long-term copper repositories. Therefore, you can configure whether a temporary copper repository should be used, or you can specify either your own copper repo or tell Packit to create a permanent one, which you can use, for example, to provide stable builds that can be installed by anyone. Progress of copper build is then reported via commit statuses in GitHub or GitLab, and we provide the link to our dashboard from where you can get to the copper build interface with all the artifacts and logs. Next, we have the test job. This job runs the test suites using TMT or FMF definition in the testing farm. Tests can use either RPMs built in copper or be run independently. As a backend, testing farm is used and tests run in disposable virtual machines. Packit provides the statuses and link to the testing farm logs and artifacts. It can be again configured for pull requests, commits, or releases. Next, we have the upstream Koji build job. Besides RPMs built in copper, you can also configure Packit to build RPMs in Koji, which is the official Fedora build system. Builds that are triggered are the Koji scratch builds. It can be again configured for pull requests, commits, or releases. Last one is the VM image build job. This is quite a new feature, building of virtual machine images in Red Hat Image Builder. It can be configured only for pull requests and runs on demand after triggering via command, as you can see in the screenshot. It requires copper builds to be built first, and then the copper builds are passed and installed in the virtual machine. After that, you can get a link to the image builder interface and can play with this virtual machine image. All these jobs I mentioned are documented in detail in our website packit.dev. I haven't covered the proposed downstream job that is part of the Fedora release automation and is covered in the previous recordings.